This is the 2002 Relative Velocity Question 2 Part B. The velocity of ship P relative to a steady wind is 20 kilometers an hour in the direction 80 degrees north of east. North of east is up here, so positive, positive. So let's write that down. The velocity of P relative to the wind is equal to 20 by the cos of 80 in the I direction plus 20 by the sine of 80 in the j direction. So what does this give us? 20 cos 80 is 3 point, what are they looking for here? Nearest kilometer, nearest degree. Okay, we'll go 3 decimals, 3.473 in the I direction plus 19.7 in the j direction. That's P. What's happening here with Q? Q relative to the same steady wind is 10 kilometers an hour south of west. South of west is going to be negative down in that direction. So the velocity of Q relative to the same wind, and we're going to be asked here for the velocity, the magnitude and direction of the velocity of ship P relative to Q. The velocity of P relative to Q. So let's have a look here. The velocity of Q relative to the wind is going to be 10 minus 10 by the cos of 20 in the I direction minus 10 by the sine of 20 in the j direction. So that's going to give minus 9.4 in the I direction minus 3.42 in the j direction. So we want the velocity of P relative to Q. So we have velocity Q relative to W. So the velocity of P relative to Q is the velocity of P minus the velocity of Q. So we need something with velocity of P and velocity of Q. We know that the velocity of P relative to the wind is the velocity of P minus the velocity of W. So therefore, the velocity of P is equal to, we bring the velocity of the wind to the left, the one that we've gotten, plus the velocity of the wind. And similarly for this one, this is going to be the velocity of Q. Down here, I'll just bring it up. The velocity of Q will be equal to the velocity of Q relative to the wind plus the velocity of the wind. So the velocity of P, this one, minus this one, the velocity of the winds will cancel. So the velocity of P relative to Q is equal to the velocity of P relative to the wind plus the velocity of the wind minus the velocity of Q relative to the wind plus the velocity of the wind. The velocity of the winds will cancel, leaving us the velocity of P relative to Q equal to the velocity of P relative to the wind minus the velocity of Q relative to the wind. So that's going to be equal to 3.473. And it's going to be minus 9.4, so plus 9.4 in the I direction. Then we're going to have 19.7, and it's going to be minus 3.42, so plus 3.42 in the j direction. That's going to give me 12.873 in the I direction, 23.12 in the j direction. That's the velocity of P relative to Q. That was part 1. The velocity of P relative to Q, and then we're asked for the magnitude and the direction of it. So the magnitude of the velocity of P relative to Q is the square root of 12.873 squared plus 23.12 squared which is giving me 26.457 kilometers an hour, which is 26 kilometers an hour to the nearest kilometer. And the direction, tan of theta, is equal to 23.12 over 12.873. Therefore theta, if we get the inverse tan of this, will give me 61 degrees to the nearest degree, and they're positive, so that's north of east for the direction and the magnitude.